Testing, going live. Here we are, people. We're live. Hey, welcome to, well, Thursday afternoon's Q&A session. My name's Blades, and this is Amberskies, the future of 3D networking. Interesting. Right, Q&A, what am I going to do today? Last week it was mainly rants. So I decided to do something more constructive today, like possibly a little bit of work. I was just doing my notes, as it were, and I realised I hadn't done the renderer. So I thought I'd do that. It's OpenGL. So if you've got any questions on OpenGL, fire away. Chat is open, so we'll wait on that. And yeah, OpenGL, look at this. We've actually got quite a lot of stuff now. About 850k we're up to. That's not bad. Anything else going on here? No, that's okay. Our core's looking a little bit despondent. I'm thinking, well, it's where do I put display? We still haven't got that answer yet. Where do we put display? It's got OpenGL in it, so we could put it into the OpenGL. I'll just leave it where it is, I think. Usually I do. GLSL's looking okay. Our OpenGL now has terrain, and we don't have a renderer for it, but we do have the generator. That's good. So let's just take this renderer for a spin. Yeah, let's do that. So what it does, it renders the model given by the vertex array object to the Windows back buffer. So how it's being used is in the main program at the moment. All we're doing is render scene and giving it a load of data to manage. That's how we're using it currently, which is okay. I mean, this will be done differently, hopefully in the future. So I've already noted that. And the render CPP, here it is, the render scene. Yeah, we've ignored, well, we've done MVP now, so I can take that one off. We've got a model, yeah, okay, I'll go that far. We don't have light. That's fine, and as you can see, there's absolutely no notes. Okay. Right, so we'll start here. We'll do notes. If you do have any questions about absolutely anything that I do or don't do, just ask. Welcome to the chat room. Let's welcome everybody, shall we? Welcome to one and all. Whoopsie daisy and all. Today's the Q&A. Why is today's wrong? What? Okay. Today's the Q&A. Wow. I mean, strict or what with the chat, huh? Red squigglies. Today's the Q&A. So ask away. There we go. OpenGL. What do I know about OpenGL? Not a lot, really. I'm not a big fan of it, funnily enough. never have been. But it's easy to use, so go figure. GL use program, yes. So that is switch on the shader. Sorry, the program to be used. Don't like that. I'm going to call it a shader program, actually. Ba-dum-bum. And this is the Open GL. Gosh. The Open GL. How can we put it? Program ID. Program identifier. Yeah. That'll do. So this is a bit weird, this one. This is a very weird function because it doesn't exactly do what you think it do. I think it does. Do. Lots of do. No. Let's get back to this. GL uniform location. Looks up an ID, to be honest with you. Yeah, looks up, let's see, finds, gets, yeah, gets the uniform variables. It's an ID again. ID from the shader program. It's actually the shader program's lookup table, if I'm going to be very strict about that, but I think that's about as much as I need to put there. The ID for the shader program, obviously. It's going to need that because it needs to know where to look. And that is the variable to find. And it's type sensitive and has to be exact. Yes, I know, but I'm not putting that in there. So that's really all these three are doing. They're just getting the MVP, model view projection. I'm going to say projection. I'm going to have to redo that. I don't know. Things. They all are different things. So let's do this line first. So copy. I've worked out what that lag is now, which is good. I can go against those two. Copy. That can go against those two. Like that. And the variable to find. Copy. And that's that bit done. So that's roughly what's happening there. We're just finding out the identification numbers for uniform variables. What are uniform variables? Right, okay, we'll do that bit next. Okay, a uniform variable is something we set once per draw call. Now the shade program will run through all of our data, but the uniform values won't change. So it's once per draw call, whereas the shader program will go through all of our data, all the positional, vertex data, the colors, the normals, and that's roughly what's going on here. So these like set things. In fact, this sets up where the positions work out to be. We haven't done it for the uniforms yet, and light, and that's why I've got that note there. Yeah, okay, I'm happy with that. Right, this will set a uniform variable a matrix and I'll call it 4x4 sets, yeah, I think that's the best way of putting it. Sets a uniform matrix 4x4 for the shader program to use. Yeah. Yeah, that's okay. That is the ID of the variable. I don't understand this line because it's only one. Number of variables. Yeah, I don't know why they've got that line in there. There must be a reason for it. Maybe it's for a certain type of calculation or modification where you can split your variables off like 1 and 2 or something like that. I don't know. I'm not really sure about that. GL faults. Does our value have to be? Does our value have? I can't say it that way either. Do we want OpenGL to modify our data? That's what it's asking, but not quite. You see, if I use my maths library, that becomes GL true. To column major. Matrices. That's really what it's saying. I use row major matrices when in my maths library. Reason being is it's easier to store row major matrices in my head. It's just the way I am. It's the way I think. I think of a matrix like you think of a page of writing. It goes across and then onto the next line, across and then onto the next line. Whereas our graphics cards don't. They go down. then back to the top, down to the next line. Yeah, okay. I can't do that when it just hurts my head. So I don't. The address for the first item of data. Yeah. So it's position 0, 0, the matrix, in other words, row 0, column 0, and it's an address, so you could put an ampersand sign at the beginning of it. Yeah, that's it. That's all there is to that one. It's a bit of a cheat, really, that, because you can use GLM to convert that without having to do it this way. I don't want to use GLM to convert it, so I'm just doing it this way because I know what that means, whereas GLM, I don't know what it's doing, and I have big problems already with what it's doing, and I'm not exactly sure that it's correct. But it seems to be doing the right thing. Seems to be. He says he's OpenGL. You see, problem with OpenGL and matrices. Now, I'm not going to go into the maths. Don't worry about that. It's just a little black box of jiggly numbers, as far as I'm concerned, for explaining. Unless somebody comes up in the chat and says, "Explain matrices to me, please." Now, how can I put it? Where's my coffee? I'm sure I had coffee. What's going on with matrices? Row major, column major. GLM. Well, once you go from GLM, which you haven't written, to OpenGL, which you haven't written, and you've just got a little black box of jiggly numbers, it becomes this horrible situation where you're not overly sure about what's going on, which is fine. That's absolutely fine. And no, don't need you to learn the maths. But what I'll warn you about is matrix calculations can give very, very, very weird results if they are just slightly done wrong. Not necessarily intentionally done wrong, but just accidentally 1x or 1y isn't multiplied but it's added, or it's added and shouldn't have been, or it's multiplied and it should have been added. If there is one little part of the whole equation which starts in one person writing something in GLM and ending up in somebody else writing something in OpenGL, and then you forget that somebody else has made the graphics card, and the graphics card is a part that does the final calculations. Oh, yeah. So there's 3 variations on the theme, and if they don't all connect perfectly, you get weird things. You seriously get weird things. Sometimes you can't even tell it's happening until it's too late. It might just only happen in a very random certain place at a certain time of the processing under a certain condition. But something weird will happen. And that is a problem. That is a big problem. Which is why I write my own maths library, so that if I spot anything going wrong with the maths, and I've written the maths myself, then that's fine. That's absolutely fine. OpenGL can take care of its side quite happily. For new viewers, if you want to ask any questions, chat's open. All I'm doing at the moment is I'm just adding my notes from way back when I should have added them anyway, and I'm just going through bits and pieces on OpenGL and things to watch out for. So it's a Q&A session, questions and answers. You want to ask a question? Go ahead, feel free. If it's not about OpenGL, still feel free. I don't mind. Any subjects, any any programming language either. I don't really mind. I think by this stage I only know about 100 or 100 plus of them. I even had to program one graphics scene in bloody binary. Think about that one. That was on a PET. Yeah, it was an IBM PET. That's going back 35 years. Yeah. That was a fun day. Working out every single 1 and 0 for a screen. Why? Because we didn't have these formulas. We didn't have OpenGL. We did graphics a different way. We used we had to write mathematical packs in assembler and get it and then peek and poke the right numbers into the right places. Yeah, peek and poke. Oh God, that takes me back. They were the days. Not. Thank God for C++. Saved my life. So let's just get this. I'm in render.cpp if anybody's following this along. It's perfectly fine. Copy that out. Yeah, go on, just paste it in. I don't think we need to change it in any way, shape or form. No, that'll be fine. And do the rest the same. Make it nice and easy on ourselves, why not? It's why I use generic language in my descriptions of what things do. More detailed language if you ask a question about it and you want more details about it. Yeah, feel free. I don't mind. So that's matrices. The bane of most programmers' lives, matrices. Wonderful thing about them is once you find out how they work, then they just work, and it's fantastic. It really is amazing what you can do with it. But we get lazy and we start using things like this. Yeah, well, whatever, that's okay. There we go. So I'm not really programming in this Q&A, by the way. It's just questions and answers. So if you do have any game-related programming issues that you want to know about, I've got a great one coming up about a movement problem. How to move the character on screen. And to address it, oh God, it's a nightmare. An absolute nightmare. I can describe it to you. It's quite fun. I might do that after. But I want to get this. I've been avoiding doing this OpenGL notation for ages. Tells graphics card which data set to use. OpenGL ID for the data set. Okay, that's that done. We haven't included textures. We're not doing for the first round, are we? No, we're not. Okay. Just colours. This is the actual bit that does the work. So, instructs. Oh. What happened to my keyboard there? Okay, what happened there? Did we just get a massive spike or something? Rather weird thing happening. Okay. Instructs. construct the GFX card to draw to the back buffer. Using the index array. Yeah. Using the index array. Yeah, that's better. Because it's draw elements, isn't it? Not draw doobies, arrays. It's a special instruction, draw elements. Yeah, that'll do. Oh, God. Weird. GL triangle. Something weird just happened on my machine there. I don't know really what it was, but hey ho. Any questions? You know, just interrupt me. It doesn't matter. It's okay. No questions. Okay. That's alright. I'll get on with the writing rubbish on my screen. GL triangles. Enumeration telling OpenGL how to draw. So it's OpenGL enumeration to describe how the draw to describe its which, and I'm going to use a horrible word now, primitive to use. Now a primitive is a basic shape, like a square, triangle, whatever. There are various things that you can use, except for GL triangles. You can use well, not in draw elements, you can't use GL quads. That one came to bite me. I don't know if you know triangle strips. I didn't look into it that far, but I should have done, I think. That could be interesting. I might look into that. Index count is the total number of indices to use. GL unsigned int, the type of the indices, in other words, how big they are. It needs to know how many bytes, and an unsigned int has a different, can have a different amount of bytes to an int, depending on the graphics card and the manufacturer. So it gives an enumeration to hide that. It's basically hiding the fact that we don't know what the manufacturer has done. Yeah, and that's the truth about it. And that is where to start in the index buffer. You don't have to start at the beginning. We can start halfway through if we only want a partial draw. So we could actually just leave, like if somebody's hand gets blown off by a 12-bore shotgun, then we wouldn't keep drawing the hand, and we might have to alter the draw elements. Instead of that, from a null pointer to something different, or whatever. Playing with the index counts and null pointers and different draws. Yeah, I don't know how it would work either. It doesn't make any sense to me. Did we actually bind up here? Got the uniforms. Bind vertex. Bind vertex array. There we go. I thought we had. There we go. So GL bind vertex array goes there. Excellent. And GL use program. It isn't switch on, it's switch to. That's very, very distinct. Switch to the shader program. Shader program. Yeah, okay, it's bad English, that. Switch over to the shader program to be used. Well, that's not quite true, but yeah, it's good enough for a biscuit. Can I get away with that one? Yeah, it's... Otherwise it'll get a bit awkward. What I'm trying not to do is over-explain. There's no point. It's OpenGL, there's nothing you can do about it. It will do the same thing for the same instruction no matter what. There we go. So that's all self-explanatory now. Let's stop that. Okay. Ugh, coffee break. That was a nice one. We did the whole file in one. Lovely. So everything's notated up now. Okay, you're notated. You're notated. You're okay. Model, well, yeah. The constructor initializes our variables and sets them to initialize value sets them to initial values. Yeah, well, that's all it does. Removes the model data from the graphics card. Yep, that's all it does. There you go. Wow. Doesn't really do much, that one. It probably does more in here. Yeah, it stores. It's all storage. It's a storage class. Constructor and destructor, are they really needed? Yes, because graphics card. We have to delete off there, so that's that done. That's all done by the looks of it. There is a part of that I don't like. Ho-hum. Not to worry about it. We don't have anything else in here, really. Unless I didn't do the generator. I didn't fully do it. I don't really want... Ah, yeah, there's more OpenGL here. Yay! More OpenGL. We've found some. Excellent. You can always tell OpenGL because I don't usually annotate it when I'm writing it. Because I have to go at a certain speed and I'm very slow to start off with without stopping. Let's have a look at these. More OpenGL to fuddle around with. Lovely. It's about time I noted this lot. Let's have a look what we got. Okay, GL. Gen vertex arrays. Haven't I done this before? I'm sure I have. This is weird. I'm getting a memory of doing this one already. Let me just check. So, programs, suppose, yeah. Module, whereabouts are we? GL Gen vertex arrays. Let me just check 9. Actually, it's easier for me if I just chuck up via Visual Studio Code, innit? Here it is. Here's Visual Studio Code. Very nice. Does it fit on this screen? Well, nearly. It'll do for a monkey's apple. Let's see. Draw entity, draw terrain. That's a render engine. It's not honestly what I'm looking for. Or is it? No, this isn't what I'm looking for at all. That's the wrong program. Let me just check over here on the other side of the world. Close tabs, please. Thank you. On the other side of the world. Yeah. I doubt they'll copyright ban me for that one. Games. This looks like something I don't want to be looking at. Okay, this is the wrong file as well. Close folder. Oh. That one. Yeah. This is it. I want to have a look at module 9. Is this where I remember it from? I bet it is. You is joking me. Okay. So why didn't I use this? Well, that was stupid of me, wasn't it? Transferring data to a graphics card. OpenGL. Well, it's me notes as well, you see. Okay. It shouldn't be VAO, it should be VAOID. GL Gen vertex arrays. Oh, yummy, yummy, yum. So what we're doing is we are going to ask the GFX card to reserve a memory block. There we go. And this is the number of memory blocks we need. The number... Well, really, it's not. It's the number of vertex arrays to generate. That's a better explanation for it. I'm just getting a bit clicky on the keyboard there. And this is the address of storage for the ID. Okay. The address in which to store the ID. It's an identification number. The ID of the array. Right, okay. I'll go with that. That sounds reasonable. What do we got here? GL bind vertex array. Switch the graphics card. Yeah, flick the switch on the graphics card. I think I meant to put there. To use a vertex array memory block. Yeah. By the way, each vertex array memory block is 32 long, unless it's a 64-bit card, I suppose, and it'll be 64 long. If it's a 32-bit card, it's 32 bits long. That's your memory block. Not very big memory blocks, because that's all it needs. It's just a it's a lookup table of identity numbers. It does go further than that, but don't worry about that. It is a bit more complicated than that. Try and move this mouse. Okay. Yeah. Okay. Switch the GFX card to use a vertex array object. And that's the ID of the vertex array to use. Yeah? I think that's right. Okay, let's go on. Let's generate some buffers. Generating buffers is always fun because it's exactly the same. So really, that line can be reused wherever we are doing that. GLGen buffers 1, and that's a positions. GLGen buffers next one. There we go. GLGen buffers next one. Yep, isn't it nice? OpenGL is just repetitiveness. But think about that, because this is all going to change very, 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 very soon. It's repetitive, but that makes it easier to work with. Oh look, there's another one. GLGen buffers. Every time I've got one of these in, the first thing that comes after it is a gen buffer. But of course, blades, that's how it works. Clean up. Just a couple of binds. Yeah, that's fine. Okay, that's your first one done. Alright, let's fill in this first now. So, the number of buffers to generate, and the address in which to store the ID of the buffer. So it repeats that line, isn't it? Come on, blades. You can do this. Of the buffer object. I suppose it should be capital, shouldn't it? And it really should be a vertex buffer object. Nobody ever asks what's the difference between a vertex array object and a vertex buffer object. Well, a vertex array object is an array of identifications of these. It's an array of these here. So that's all it's going to hold. But it also, because we've bound it, it's recording what we're doing. It's like a macro recorder. If you download a macro recorder, it works in the same way, and it will record whatever we're doing. So that's nice. The number of buffers to generate, copy you. Here we go. Just pop all these in. Saves us having to redo them again. Nice and easy. Nice and easy. Yeah, that's looking good. So this is going to start filling up nice and easily now. If you're wondering, are these all necessary? In my opinion, yes. And that's just my opinion. You can write programs without them. You don't have to split these down on different lines. You can just write straight across the screen. But, hey, cause yourself problems later on if you want. I don't mind. Because you will. I can put programs that I've written up on screen and say, what does this program do? And I can't answer the question. And I wrote them. I know I wrote them. No idea what they do. Couldn't even begin to work it out. But when you start doing this and breaking it all down, then it becomes very easy to know what the program is doing. Okay, so we've got a bind buffer. So that's a copy. Now we'll put it there. GL bind buffer. Vertex buffer object. Okay, it's not an array now, it's an actual buffer within the array. So that's good. Nice and easy. Nice and easy. And there we go. Well, you can see it's just repetition. It's not a problem. So it might look like there's a load of code, but that's all the code there is between those two lines going across. So it's pretty obvious what's going on, really. There's not that much. It just looks different. Yeah, I did them all, didn't I? Yeah. 1, 2, 3, yeah, 4. That's it, yeah, it's 4 of them. GL array buffer. How do I want to... it's an OpenGL enumeration. What's an enumeration? An enumeration is a number turned into a word or a word turned into a number. What it means is it's been given a name. So a number has been given a name. If I hover over that, it's a number. Hash defined GL array buffer. It's in hexadecimal 8892. So OX means hexadecimal, 8892 is the number. There you go. So what is a GL array buffer? Well, the code for it on the... God, not the graphics card, but the code that has been picked up by Glue. The code that the Glue has picked up for us is 8892 in hexadecimal. That's a good way of putting it. Glue's doing all that for us. That's why I've included it. 4. OpenGL. Enumeration for the type of buffer to use. So that just tells the graphics card, using that code, which type of buffer we're using, and that's the ID of the buffer. The buffer's ID. Is that right? Yeah. It's right. Copy. Doesn't agree with my notes, like, but hey ho. The more times I do it, the better it becomes usually. Or more understandable it becomes. My notes sometimes aren't that understandable. Even I have to admit. So we'll just pop them all in, shall we? Excellent. Copy. I think that's a better way of putting that last line anyway. Yeah, so we're building this up nicely into a fully annotated code base. That's looking a lot better. Okay. GL buffer data. Oh, this is a good one. What can we say about that? Well, as no questions have come in, I suppose better think of something. Oh dear, that's, yeah. Let's see now, what do my notes say? Send data to the graphics card. Yeah, okay, we'll use that. Send data to the GFX card. There we go. That's an OpenGL enumeration, type of buffer again. But this time it isn't to use, it's in use. A difference again. I know it's only one word in English, but it's a different meaning. Gives the whole thing a different, well, context. Really? And the next bit is, oh god, that is an awful thing to put in. It's correct. Actually, that is the best way I have found of doing it. That's an awful thing to say, isn't it? Because all it actually is the number of bytes of data. In other words, how many bytes of data do you want to transfer into the buffer on the graphics card? There you go. That's all that is. Nothing hilariously funny, which I originally thought it was going to be, but it isn't. Positions. Positions. Yeah, it is actually, yeah. The address where the data will be found, and that's the need one. A hint to OpenGL for data usage. That's more important than people. I mean, most people I've seen, they always say, "Oh, it's only a hint. It doesn't really matter. Just put GL static draw there every time, and you'll be fine." No, don't. Look up the differences and the different types of things you can have in there, like GL dynamic draw, for instance. That would be when you are morphing a model. You would have a GL dynamic draw situation where a model morphs into something slightly different. Now, this affects how and where the data is stored, whether it's stored in high priority, medium priority, or low priority memory, because nanoseconds in the life of a graphics card processing unit, the GPU, 1 nanosecond in its life cycle is a long time. It would be like 1 nanosecond to us as human beings would equate to at least 5 seconds, maybe. So, you could equate it to 1 second, I suppose. I mean, that makes it a more easy to identify thing. What we can do in 1 second, it can do in 1 nanosecond type of thing. If you think about the scales of that, it means that your GPU it can do 1 million calculations per second. It can do an awful lot of data crunching. It's why they use GPU style setups in data centers for servers. But that's a different story. But what they usually go for there is amount of cores and threads, whereas the GPU goes for maximum power crunch for heat output. Data centers don't care about it too much. They just have big noisy fans going, whereas a computer like this one has no fans. Yeah, my computer has no fans in it. So, yeah. Interesting. This will be the same for each of those. Just realise what I'm doing. Copy. Ain't gonna change just because it's on a different line. Put it there. Why did I just do that? That was stupid of me. There we go. That's better. Open jelly enumeration type above D. Yep, that's good. Can copy that one. But you can see why a server, you have to set a server up differently, because a server is just about data crunching. So you'd set a server up in a way, in a similar kind of way that you would set up a graphics card, which is quite different to a computer. So when I say I had to go out and buy a server, I actually meant it. I have had to go out and buy a server. Luckily, they're not expensive. They're not as expensive as a PC. If you get the small ones, like an office one, a small office one, and then you just download Ubuntu onto a USB, and Bob's your uncle, off you go. And that's it, you've got yourselves a server. Quite easy. Server management isn't, but that's a different story. Building a server's very easy. Managing the server means you need to give it attention. So it's not very easy. Yes, requires effort to run a server. The address where the data will be found. Yeah, okay. That's that one. And that one. Well, this is working out nicer than I expected. It's a bit more relaxing than a normal day. Trying to crash through code at a quick pace and failing miserably, which is one of the things I am finding with doing these live, is that I'm actually trying to program too fast, which is a bit unfortunate because it means I'm not thinking about things properly, and that is never a good state of affairs, especially with 3D. It's not easy to think in 3D to start off with. So it's usually better to take your time and get it right, which is why I had to use experimental 3D to get it right in the first place, but we've got it there. It's there. We've got our terrain. I'm a happy bunny. That's all I wanted this week, was the terrain. There we go. That's that. I think we'll go and play a game after this. Yep, I think we will, because there's not really much of this to do. So that's GL bind vertex array again, isn't it? Yeah. I've already done that once. That's GL bind vertex array. We can copy that one to the bottom. About there will do. GL bind buffer. 2 of those. Gosh, this is difficult. I can do it with one hand. Look at this. GL bind buffer. Just putting all my notes together. When I come back to this later, trust me, I will have to read them. Because it tells me where I am in the code. Which is more important than what the code is doing at some time. Sometimes, anyway. Yeah, that's looking good there. I've got the zeros in. And bind buffer has a second value. Okay, copy. And that's why there are 2 of the bind buffers here. 1 for each type of buffer. Okay, and then we've just got to fill the zeros in. What are we going to put for 0? That's a good question. What shall I put for the zeros? I'll finish this off quite quickly, can't I? I'm just going to put zero equals switch off. In other words, don't use any. I think that's the best way of putting it. Switch off. Yeah, that'll do. That'll do nicely. Alright, that's that bottom section all done now. So now all we've got left is 3 lots of this, 0, 1 and 2 of this, these 2 instructions. Okay. It's looking good now. Look at this, it's starting to look like proper programming. Except for this bit, which looks like a load of rubbish. Is it a load of rubbish though? No, it isn't. It's actually a good code. Damn. Ah. I've just been saying that zeros equal off, and it doesn't here, does it? Okay. Not always in OpenGL does 0 mean off. Okay. You can never be right with OpenGL. It's impossible. It will contradict you no matter what you do. So let's enable something, shall we? Switch on the attribute. Yeah. Okay. Attribute. I think that's how you spell it, isn't it? Yeah, it is. And that is the attribute to switch on. Yeah, right, funny. we go. I think that's a better way of putting it. 0 equals positions. See the shader for layout. And the shader will actually confirm it. So there's the shader. There's your vertex. Positions. Layout. 0. There you go. Confirms it. Which is cute. But that's exactly what it means, by the way. That links all of this, data and everything, links everything here to that program there. Very clever system. And it's all done for you. Ain't that nice? It's free. You get it free. Yay! I'll have another tab on that, thanks. Right, okay. There isn't one down here, is there? No. Should just be 3 now. The index array doesn't have an attribute. Positions, normals, and colours do. The index array is what is used to draw. That's the draw elements bit back in the renderer when I came to draw the elements. That ties in with that. Instead, so where am I up to with this now? Switch on the attribute, okay. Nearly done. Not taking long at all. Oh well, looks like I am going to get to play a game. Getting through this too fast. What shall I play? Okay. Alright. Just looked up at the screens and around all the different information, got completely lost in it. Right, so I have to alter these, don't I? So 1 equals the normals. And 2 equals the colours. There we go. There we are. Colours. Lovely. Fantastic. We're on to our last one now. Is that correct? That is correct. It's looking a bit more healthy. God, I'm glad I'm doing it this way. It's the first time I've made a rule, and I'm sticking to it this time, that everything has to be noted. I'm not going to do another program where things are just splattered on the screen and then left to rot. I've given up doing that. Alright. This is an interesting one. This tells the GFX card how to use the data. I think that's a good way of putting it. No, it's not. About the attribute. I'm going to stick to that because that's more accurate. It doesn't really say how to use the data. The shader says how to use the data. We program that. This just tells it about this attribute. This 0th position for positions, yeah. Oops. Alright, what we got here, 0 is... I think that's the same as the other one, isn't it? So that gets from there. So really I can copy that one out. And that's the same as that. And that is the same as that. Nothing difficult going on here, and no questions. Okay. That's good. Means I'm going to get to enjoy myself. Right, back to the zeroth. Looking very good. What does this number 4 mean? It's the number of items of data, isn't it? Yeah. How many items make up one data set? And in this case, it's X, comma, Y, comma, Z, comma, W is what we've asked for. Okay, I'll take that. In other words, for a position, it needs to know the X, Y, and Z coordinate plus a fourth dimensional homogeneous coordinate. I'm not really sure how you want to pronounce that. It's because I'll keep listening to American stuff, I suppose. Homogeneous, I think we might say in England, homogeneous, where in America they would say homogeneous, which doesn't sound right to me. But hey ho. Okay, I'll do the bottom one first. Oh no, I won't. I'll do this one first, next. Doesn't matter, they're all different. Slightly. For normals, we don't need the W. Should I say we don't use the W? Doesn't need it. Because that's a vector, not a position. And a vector doesn't have a position. It's just direction and magnitude. There you go. But you never knew that about that one. That set of data is slightly different. And we will be treating it differently, as you will no doubt see very, very soon. That's that one done. And this one is nearly correct. But this is different. This is now R, G, B, and A. No, small a. Alpha. Visibility, invisibility, see-throughness, opaqueness, I think the word is. Thank you, Blades, for your diction. GL float. Again, that's an OpenGL enumeration. And what is it describing? The type of the data. So it's an open GL enumeration for the data type. And that's the truth. Next line. The one that nobody wants to talk about, so I will. Which is typical of me. I'll talk about all the things that nobody else wants to talk about. Because that's what I do. Checking cues, no. Okay. So it's this falsy thingy, isn't it? GL false. What are we saying no, don't do? And on this one we've got GL true. Yes. And on here we've got GL false. Yes, so it's different. So what is that? What is the graphics card on about here? It's, do we want the GFX card to normalize our data? What does that mean? Yeah. It means do some mathematical function upon our jiggly bits. If it's a vector, which this isn't, and this is a position, so normalizing it is pointless, because normalizing is done to a vector. So in vector mathematics, to normalize it means that the magnitude is reduced. So each part, the x, y, z of the vector, is lowered until the magnitude equals 1. If you want to know how that's done, it's using Pythagoras' theorem, x squared, y squared, z squared, root equals 1. There you go. That's just off the top of my head. Or 1 equals the square root of, yeah. It's just Pythag theorem. Now you'll see that, hold on a minute, we've got GL true here. Why is that? Because this is a vector. As I said, normals are vectors and not positions. They don't have a position. They are a magnitude and a direction. And normals are better used in equations in our shaders when they are normalized. If we pass them in and we don't normalize them in our shader, we're still going to normalize them. So one way or another, that vector's bloody well going to equal a magnitude of 1, whether it likes it or not. So there, Mr. Vector, you will equal 1. It's because of a special technique that we use for angles and percentages. I'm going to call it percentages, using the percentage of an angle to reflection for light. If you think of a percentage of light reflecting off a surface, and that's how bright that surface is, then if you don't set your magnitude to 1, all the equations go out the window and really do mess up. So that's why we do it. This one's colour, and that's the position of its colour. Sorry, this is not a vector, so it's false. Simple as. Anything that's not a vector. You can have vectors being passed in that are not equal to 1, and so you put GL false. Simple as, it's your choice. A lot of people on the internet will say, oh, just leave it as false. Why? Why not do what it's meant to do? That is so fast, because as it's loading our data, it will be normalizing it, which means it just sends it through a little side circuit that it doesn't send normal data through. And it doesn't do a lot in that little side circuit, so it doesn't cost any more time. That's a massive time saver. To actually put it in and then normalize it means you put it through and bypassed that extra circuit, or bypass that side sub-circuit. You've gone in, and then you're having to send all your data out, send it back in through the sub-circuit and back in. So you have to copy it back out into a temporary memory slot area. No, I'm not going to describe what they are. And it then has to come back and give you the result through that little circuit. Now, it's still damn fast doing that, but there is a copy included in that assignment, and that means it's damn slow compared to that, which is doing it as we filter in the data. Yeah. I wish people would tell you that. I just wish more people who taught OpenGL would really tell people the truth about this line. It's not hard. I've just done it. So how hard can it be? I mean, you're talking about blades here. I'm not the brightest spark. In fact, I'm probably, yeah, a bit of a Dumbo at times. Okay, we've done that one now. We're getting towards the end here. What's going on? Oh, we've got 2 lines to do now, have we? 2 lines to name. Or describe, should I say. Describe. Describe my data, sir. And that's really what we're doing here. The attribute pointer. How far is it between each set of data? That's the correct answer to what I'm looking at. But instead, I'm going to put in the total size in bytes of one data set. So it's the total size in bytes of one data set, which is why we've got that times 4 on it. Because if you remember how many items are in the data, well, there's 4 of them. Enumeration, data type, GL float. So it knows there's 4 GL floats. Why it's asking us this, I don't know. I don't know. The data is on the graphics card. I don't know why it asks us that question. It's probably just to save time working it out later, I suppose. So it doesn't have to do a calculation, makes an optimization. I don't know. Where to start reading data from, where to start in the buffer, where to start, okay, where in the buffer to start reading data from. That's possibly the best line I can come up with. Okay, let's get this one settled. So just copy and paste and we're done. No questions, yay. Cheap and easy day for me. Nice. Just pop these in nicely, which means I now have files updated and correct for once. Starting to look good because I want to transfer all of this stuff and I want it all notating for when I transfer it, so I don't mess anything up. Nice. So happy when a plan comes together. See, this is a terrain generator. Well, this also happens to be a big part of what a model loader does. When you load a model, you first of all have to set up the data so it can be read into the graphics card, and then you still have to go through all of this to put it on the graphics card. So model loaders use this code as well, and that's why I've notated it all up. Okay, so that code could actually be taken out of terrain generator and put in as a utility. Ooh. Yeah, but we need to get all of this lot back. Yeah, I'll just put it here. Here'll do. We store the IDs given by the GFX card into the models storage class. I think that's a fair deal for that lot. And return the complete set of model data required for rendering. Ding. Done. Not a bad one. Not a bad one at all. I like this now. Yeah, I like this now. There we go, 1.5 hours work. Not bad. Done. So, last ask for questions. I finished noting up the terrain generator. Done all the notes I wanted to do today. Next week, we will be venturing into the next stage of this. I'm thinking of making a player for our game. Because we've got the terrain. Oh, we haven't got the terrain render and stuff sorted out. Does that matter? I'm going to need a set of notes for this, aren't I? Yeah, I am. This'll do. So next week or next, let's have empty files are terrain renderer. So empty files. I tend to do this. I'll put a file in and I'll just leave it empty. And I'll never remember to do it. So we have terrain renderer. Oh, terrain render. Okay. What else do we have? Camera we've got. That's not empty, is it? No. Terrain models. Well, should it be empty? No. Render CPP is done. Terrain render empty. Terrain generator done. So that's the OpenGL side. Shaders have all been done. Yeah. Display's now been done. I did a couple more bits and pieces that I'd missed. That's all done in there. Core has been done. File handlers. Yeah, okay. That was a thought I had the other day, so I'll put that down as well. Can I have my note back, please? Thank you. Terrain renderer. So, under file handlers, we could do with a save file. I don't like saying technique. Function method. I don't like the word function either, so I'm going to use Java's usage of the word function and call it a method. Terrain renderer. Yeah, okay. Right, so that's that. But I do want to look at next week, especially next week. We have light to do, definitely, and then we have the user/player to think about. And I think that's all I'm going to need at this stage to be concentrating on. If I just put those two down, that's enough to keep me going for a couple of weeks, probably. Yeah. Gosh, I didn't realise it was only the terrain render we hadn't finished. I thought we wouldn't get through half of it. And as you can see, week 2, it's creeping up. Not a lot, but it's creeping up. Oh dear. Mind you, if I throw GLM out and use my own master library, that would go down, I bet. Now, that would be a good test at the beginning of next week, but that's a lot of work, isn't it, for little reward. Damn good thought, though. There we go. That's where we're up to. Next week, we're looking at light and player. Well, light. First of all, light is going to be hard to do, I think. The player is just going to be a bit of a fun dabbly thingy that I'm going to mess about with. Could be interesting. Maybe not. In the meantime, if you do have any further questions, email. Whoops. Yep, I've got an email here. Contact email there. Or pop over to the website. There's contact buttons on there. Twitch, obviously. If you want to help me on this Twitch channel, click follow, I think it is. If you want to help me on the YouTube side, subscribe, like the video, and put replies down, or, comments below thingy type of thing. You can ask questions in the comments. Yay, you don't even need to email me. In the meantime, take care, have fun.